Hey y'all. So first off, I apologize about the noise from the printer. I'm printing my master plan, but I am printing the next iteration of the rotor. And here I'm just spinning this rotor. I guess the first thing I'd say is those ceramic bearings are out of sight. So here I'm just spinning the rotor in a conventional fashion, like you would with a bitty schoolgirl type setup. So we're drawing 20 milliamps, 10 volts, and without any load. Last I checked, it's spinning at 1560 RPMs, and it was still climbing a little bit. So again, those bearings are good, and you know, it's 3D printing. You get things printed well. So I want to really just show basically a couple things that are mysterious to me. So it's like, what's dictating this amp draw? And there are a few things. First, if I can slow this down, let's just slow it way the heck down. Now that's not because I'm loading it. The reason that the amp draw has gone up is because you have a longer pulse, and because of the reactance of the coil, you're getting more towards the saturation. Initially, the pulse will be seeing great resistance, and then as you get as the pulse goes longer and longer, there's less and less resistance till you're finally with the coil fully saturated just at the straight DC line resistance. And so when you're going slow, you have a longer pulse. Now you have a shorter pulse, and so there are less amps going through the coil because of the reactance of the coil. And as that spins up to where it was before, we'll go back down to 2. So that's one thing affecting the amp draw. Now another thing, well, of course, one other thing is how far the sensor is away from the magnets, because, you know, if you have it in close, the duty cycle will be longer, and so, you know, you'd need faster RPMs for a shorter pulse than if you're out there and it just, you know, goes for a brief second and goes even a briefer time as it spins faster. So that's fine where it's at. Now another thing that changes I'm going to try and keep this with the same air gap, and you know, I've done this plenty of times, so this is the first time doing it with this setup. So I'm just going to move it around, like I'm moving over here. We're up to 3, and wait, now we're down to 1. I turned this like that. Wow, we're down to less than 10, 7 or 8. Okay, that was mainly the distance, but there's a spot, I'm having trouble showing it, but there's a spot here and here, you know, around there like that, where now I can't tell how much. I might just be moving the coil a little closer or further away, but you do see that there's a spot there where you want it to be. So there's that. So now let's keep it here. We'll let it spin up. I don't know what we're spinning at. I'm guessing, you know, between 12 and 1600. We're drawing 16 milliamps. Now what I'm going to do is shove the coil in close, and we can see the amp draw as that. That's the negative there on the left hand side. Now also look at the voltage. This was at 10 volts okay? But now it's saying, well, we're at 14 volts. This is at -6, and the rotor's slowing down, and as the rotor slows down, this will then flip positive again. So I admit that one's a mystery to me. And with it in this close, we're probably not even going to get to, we might not even get to 5 milliamps. But it's going to be going, 400 RPMs. Geez, we're not even going past 3 milliamps. Isn't that kind of neat? So that's kind of the first mystery. And I don't mean that like, oh, I've got it figured out, you got to guess. I mean, like, I don't know what the hell's going on. I mean, why does it do that? There's not, the bridge rectifier is not doing anything. It's just off into space. It's a road to nowhere. There's nothing feeding back to this. Look at this. We're at 1.6 milliamps, although it's going slowly. There's nothing. Somehow this is rectified back to source, and it's rectified back to source based on the magnetic flux of the moving magnet. Otherwise, when the thing was spinning fast and then we brought it in with it still spinning fast from its inertia, from its momentum, it wouldn't have flipped negative. But we'll do it one more time, just for the heck of it. So now we'll bring this out, and again, so the amp draws high, then it's going to go down with this in the same place because of the reactance of the coil. And keep in mind, when it's going slow, the pulse is longer, but you're still drawing so little amp draw. So in other words, the reactance is working against you. Sorry. I'm sometimes not the brightest. The reactance is working against you when you're when the rotor's slowed down. So that decrease in amp draw is overwhelming the increase in amp draw from the longer pulse. So I think we have it spun up about enough now. We're drawing 25 milliamps. When I bring it in, I want you to pay attention. I don't know if I can do this. I want you to try to pay attention both to the amp draw and the voltage on here. So let's bring it in right now. Voltage, amp draw. I can't show them both. Voltage. Remember, we started at 10. Amp draw. Now, as the rotor slows down, the amp draw is becoming less negative, and the voltage is returning back towards 10. For some reason, this never seemed to change from 0.01, even though this is saying negative 0.053. And that's neither here nor there. So now, well, we're still at negative whatever there, but eventually we'll get back to where we're drawing 1 or 2 or 3 milliamps. So again, I don't have the answer. I'm asking the question, how is it getting rectified? I mean, it's getting rectified. The spinning magnets are getting rectified back to your input source. Doesn't matter really where you put it. It could be at this angle where you're drawing, say, a little more to start with, or this angle where you're drawing a little less because there's a sweet spot there. You want that 22 degrees thing. Although I guess that's less of an issue with bipolar. But kind of no matter where you put it, as long as you can get the thing spinning, it does that. So it's not like you have to have it dialed exactly in somewhere, but it gets rectified. Didn't get rectified, then how did that go negative? Okay, now we're at 2 milliamps. So here we have it set up window motor style, and I've said as I've said about 10 times now. You know, this is not the right way to set up a window motor, because that's all your motive force there, and the rest is waste, but it's what I had available. So we're drawing here about 130 milliamps. It's not going real fast. It was going faster before. But what I can do here, now what I can't do is I can't change the air gap like we were doing before. But this, when I move this thing around, the air gap stays constant. It has to. And so that's another way you can see that there are places where we didn't change the air gap. And listen, it sped up. Now we're drawing 20 milliamps. Now, here's what I want to point out to you. I don't know why I laughed. I kind of sounded like a school marm there. But here I found a nice spot, and it's spinning very fast. Now, recall when the other coil was shoved in, the amp draw went negative and voltage went high. You know, like instead of 10 it went to like 15 or even 20. And then when the amp draw came back positive, the voltage was back to 10. You can already kind of see what I might be getting at here. So keep an eye on the voltage and the amp draw, if I can show them both here. Well, out there is bad. Although I guess it's speeding up. And you know, again, you do get the reactance of the coil thing. As it speeds up, the reactance means you draw less. But now we'll go the other, now I'm going to go this way. So now, whoop, you heard it already. You know, we're back to negative, but there's something a little bit different here. We're going to let this thing settle down to its normal state. This is another wrinkle on the mystery. And so this thing has been there for, you know, 30 seconds now. We're drawing 14 milliamps, but there's the input voltage. And I had thought initially when I was seeing this, like, oh no, this thing's going hinky. Is that a word? But here, I'll disconnect it. See, we're at 10. You know, this thing isn't wandering around. Now I'll connect it up again. This thing isn't wandering around. So I've connected it up again. And it's back to there. So you tell me, what does that mean? What does that mean? Well, I don't understand why the first one worked, how it was getting rectified. At least it made sense that the voltage increased above source when the amp draw was negative. Now you have a case where you have a positive amp draw, but you have voltage above source. I mean, how can that be? I don't know what the heck John Bedini was talking about, but you know, he would sometimes use that phrase, maybe your meters aren't showing you what you think they're showing you. So, I mean, for this to be 12.5, that means current has to be flowing back to source. For this to be 14 milliamps there, that means current has to be coming out. How can current be coming out from 10 volts into 12.5? You see the problem? How can that be? How can current can't flow uphill, but it is? Or, you know, I don't, maybe this isn't showing me what I think it's showing me. Maybe there are two currents. There's one going out, and then there's one going back, and somehow never the twain shall meet. So I ran it off batteries where, you know, I actually didn't check if I had it set up right. whether the voltage was going higher than source. But I had it set up, about like that, and I figure, oh, it's got to be about in the right place. But it did drop from, I want to say, about 11.83 to 11.73 over 10 hours, which would have been consistent with the 20 or 30 milliamp draw, which, with the setup I had there, was, it would have been about half that with this amp draw. But, I mean, I had it set up a particular way and had it taped down. But I'm still stuck with the fact that I think there's current also flowing back. So, fascinating. All right, here I'm just poking around, rotating this thing. Got it at 12.4 there, and we're down to 9. Pretty soon here, it's gonna want to spin the other way. Oh yeah, oh yeah. Stay there. Ah, rats. I think it already wants to spin the other way. What if we go back a little this way? No, very bad. But the voltage there is climbing. So it's like, what am I trying to engineer for? A negative amp flow, or this, or is that negative amp flow? In which case you'd want it there where the speeds up. And that goes higher. So, if there's one thing that's clear, it's I don't know what the heck I'm doing. But now the rotor's stopping because it wants to spin the other way now. So it can't be there. So, having fun with this, but even though I don't understand, so there's a pretty good one, 10, but it's 11.9, and that's 5 milliamps, and it's spinning, yeah, okay. But what I'll say is, even though I don't understand how things are being rectified back to source, there's no diodes or anything involved, and it doesn't seem position dependent. I mean, I don't know how it's magic, or I'm a moron, or a combination, or maybe I'm not a moron. But I don't understand how it's rectified back to source, and then I further don't understand how you can have current being fed back such that the voltage of your source is higher than it started. This is, as I showed when I pulled the thing off, this is at 10 volts. Now it's at 11.9, yet current is flowing from 10 to 11.9. So it's the only thing I can think of is it's like two different currents. But this one, would have to be feeding back, right? I mean, you can hear also, if I can find it, there are places where I think there are two relays, that trip on this thing between, like 0 to 8 volts, and then when it goes to 8 to 20, it trips to either a different coil or a different tap, and then 20 to 50 a different tap, and you can hear those. There, you hear that? Boom, boom, boom. So this isn't just something showing up as a digit. This is something that's tripping a relay. So it's like, it's physically there. All right. So kind of just to wrap up, even though I don't know what's going on, the sort of take home that I get from this, and also, I just recall, let me shut this off. I don't want to bump my fingers again. When people make these, they make it, like that, and this going like that, and then, just a little there, and then it goes like that, and that's how you're supposed to make it. And so with that, if things are feeding back, and we know they're feeding back based on the rotation and the flux from here, then there'd be a lot more of that, and you'd also have a lot more in terms of like motive power going on, and so it's not clear exactly what that would do. So the first thing, but you know, everyone builds them that way. Everyone now I'm like resorting to propaganda. That's the way that I've seen them demonstrated as they should be built, and you can expect at least that they would have more motive force with more magnets coming to bear. You'd be making more efficient use of the coil for a given amount of wire, and whatever's going on with that, see, I'm spinning it, just spinning it. Doesn't matter which way I spin it, and there's no what is going on there? There's no rectifying diodes or anything like that, but that's what happens when you spin it. Okay, pardon me for this, but I just learned something. It's hard to do with just one hand. So, spinning it that way, positive, nothing's changed. I can't spin it this way. Spinning it that way, negative. Now I'm going to spin it fast as I can. No, that's not good. Oh, I know. I'll just spin it up and disconnect the wires. Okay, here I have it spinning at, I don't know, maybe 700 RPMs. We're going to shut this off. It does matter. It does matter the orientation of this. In some orientations, I'm getting it feeding back positive, and in some orientations, I'm getting it feeding back negative. So that's very interesting. Let me try one more here. Yeah, okay. So that at least confirms that it can go back. But in other orientations, I saw it as going positive. If you recall, in a previous video, I mentioned a video by Dad Have, and he took a window motor, spun it, and he used that to charge the caps. So if this was going negative, then that would be something that would like charge the caps. And we see that it can go negative. I don't understand how that happens, but it does. And it seems to be something that is positionally related to when the trigger is. But I'm gonna work on that on my own to confirm. But the long and short, as I think I was saying, is we want to extend this row of magnets, and so that's what I'm printing right now, is to have a second row. The problem I have is I should have ordered square magnets, because with these circular magnets, I mean, I first just put one in, you know, with like an 1/8 or 1/4 inch air gap. It was horrible. And when I actually put a magnet as a magnet sensor, I could feel, say this is north, I could feel the south between the two. So you need a magnetic flux path, and I'm hoping if I just have the two just touching, you know, it's like electricity, I'm hoping that that'll be enough of a flux path that I can just do that. I've rambled enough. In the last video, I'm going to run this thing with a capacitor in with different pulse timings related to the resonance, and that'll be fun. But what I'm really looking forward to is adding a second row of magnets and seeing whether I get improvement. And also, I'm going to, when I add that second row of magnets, that's when I'm going to, you know, make some coils that really are just, you know, like truncating that, just like that. You know, it's like, I don't think there needs to be any air gap. Just bring them around like that. I could be wrong about not needing much of an air gap, but that's, you know, that'll be good too. I'm rambling at this point, but I'm having fun. I hope people are having fun following along with all this. Thank you. Bye.